Welcome back to Cyber Prophets, a place where we prophesize the future of technologies. And tonight, in a special event, we're going to have Gabriela, which is one of those women in IT, one of those special people that you can not see very often. She works in the area of data analytics, one of the areas that is increasing drastically, and the importance of it in our current world is very important. And tonight I'm going to be with my co-host Edgar Regalado. Edgar?
Hello, everyone, and it's a pleasure to be here with you again. And I am glad to be the co-host of this show today. And we're very glad to have Gabby today in our show.
And Gabi is someone that is also very unique. She was born in Mexico and nowadays she's working in Germany. So you can imagine that there are a lot of secrets that you can discover about this interesting woman. What else? She's a basketball player. But tonight we're going to focus more on the other hobby that is connected to data analytics. And maybe she can introduce a bit what is data analytics for our audience.
Hi, Edgar and Federico. Thank you so much for the invitation to be here on this podcast. Data analytics is like the sexiest job since the latest 10 years. Everybody wants to get in there. But it's not that hard to understand. Actually, data analytics is just gathering insights, meaningful insights from data to solve actual business problems. That is the huge main purpose of data analytics in general. It is a very recent branch from IT, and it has completely evolved throughout the last 20 years, which is something that we will talk about during the podcast.
Amazing, Gabby. Thanks for the concept. And I have to be honest, even though I'm involved in IT, I'm a software developer, but data analytics is quite still a blurry concept for me. I'm not quite sure what is going on there. So could you please tell us a bit more about your experience? Like, what do you do regarding data analytics, and what is your job about, and these kind of things?
Okay, as such analytics, it started more or less in the mid 1990s. Back then, it was mostly known as a part that came out from database, the development, database maintenance. So we have the typical database administrators, and we have the users who use this data stored. Back then, it was actually known as data mining, and it was all the rage in those days. Yeah, it was the most basic thing.
Yeah.
Data mining, it's still very much in use today, or also known as knowledge discovery. Those are the two keywords we heard back in the early 2000s. Today, data mining is actually one of the tasks used by data scientists, which is the sexiest job ever. Everybody chases it because it's really well paid.
Oh, yeah.
But it's more about what are we doing with all this data that we are gathering, because now we have a lot of CPU power, the storage capacity is a lot cheaper. So every single transaction we do every day, from the data you use in your phone, from all the orders sent from Amazon to all the usage in the network, whatever you can imagine, it is now stored. So how can we make use of this? That is where the power of data analytics comes in. There are several steps of it's called maturity model of data. It was actually developed by Gartner. They usually come up with this magic quadrant every year.
Yeah.
And Gartner found a way to catalog how to harness the power of data. We usually start with what is known as descriptive analytics, which they look to answer what happened. And it's what we have mostly called reports. That you just say, okay, yesterday we sold this many t-shirts. Yesterday we had this many users in our network. That is looking to the past. The next step on this model, it is about getting actual insights from this data. Okay, we know yesterday we sold 200 t-shirts, but how did it happen? Can we look deeper down into the data using the knowledge we already know from the domain, from our company? How did this happen? What was influencing that we sold so many t-shirts? next step in the model, they call it predictive analytics. When we are looking to answer what will happen. So yes, we know that yesterday we sold 200. But what about if we add one more variable, if we add influence, what will happen in the future? And the highest level so far is what they call it prescriptive. So if we add these variables, we know that we can sell more t-shirts. Okay, can we structure the plan in order to reach this goal? Can we maybe make more scenarios and map each of these scenarios? How can we make it happen? And this is more or less how a company matures in the development, the use of the data, and this is where the different roles that we hear today on the data engineer, data analytics, data scientist, they slowly fall into these categories.
So if I understood correctly, you have the data and you analyze the data to find out how things happened, looking into the past. Then you start making predictions about it. And the last step is trying to create plans or to adapt your model in order to reach a certain
this
goal.
prediction. Exactly.
Aha. Okay, so in this sense, like it can be used, data analysis can be also used for the creation of sales plans, for instance.
Absolutely. It is one of the most valuable things in use today.
Amazing, amazing. I knew, for instance, that you could use it, for instance, for marketing. Now you have clarified that it can also be used for sales plans. So may I ask you, like, what are there, like, any other benefits from the use of data analytics? Like, in what other areas could this be applied?
A lot in the industry for predictive maintenance. For example, any kind of machinery production line that you start gathering all, companies would more or less know what is a normal level of production or how the machine should work. And they can always monitor if after a certain time of use, they need maintenance, or if they have a normal way of working, and they can send a message and say, okay, now we need maintenance. So it's really useful for, especially in production, where you can nowadays automate a lot of these things.
So that when you're, let's say, going into that part about automation that you mentioned, how do you combine it? Because generally, in my experience working with RPAs, we mostly is like automate like predictive things. But how do you combine this area? Because the other I see it more like I do predictions, and the other I see it more like the actions.
Okay, when I mean automation, I was more referring on a production line, the typical production line where we are passing. If you mention on the automation as in, for example, chatbots would be the most, that involves a lot more of natural language processing, which is also one of the areas explored in not data analytics per se, but more in the area of data science, because it definitely involves a lot of language recognition. And then you go more into statistics, cleaning data, which is a slightly different area, which we can also go into detail during the podcast.
And for you, for example, when you joined to the data analytics world, what was the greatest challenge you have faced?
I think the greatest challenge today, and not just in analytics, probably in everybody working in IT, is this disconnection between the IT people and the business side. That there is some kind of misunderstanding. That is something I experienced. I previously worked as a test engineer, and it feels like we are both fighting, which it shouldn't be, because IT is here to support the business. We don't generate revenue per se unless you are a consultancy. And I found value on being able to understand the business, have this domain knowledge in order to influence them, support, persuade them, and make these insights valuable so they can be further implemented. Because that's something that should be clear to anybody working in data. If you can create the perfect model, but if the business side doesn't understand it and they don't implement it, your work is worthless.
Exactly. So in your experience, how can you improve the communication between IT and the business? How can you make yourself understandable, or that can you understand the business terms?
That is something we are actually working on in my current company. It's from both sides. We had to start first understanding the business people and then influence them and create a structured data culture that they trust the data you are presenting them, that they trust the numbers, because many of the business people only rely on their intuition. I recently had a talk even with the CFO, the Chief Financial Officer,
Wow.
and he admitted that many of the things he does, even if he has the data, he still relies on his intuition and how many years of experience I have. But what about if you can make a better informed decision based on facts that you already have here? Wouldn't it be give you a further insight and not just rely, because our memory is really bad.
Exactly.
So that is definitely something that we as analytics people, we should step into their shoes and help them create this data culture, so they, once they understand, then they can really make use of what we are offering them.
And I can relate a lot with what you're sharing, that let's say that they follow their guts, because it happened with me that sometimes I was trying to give some advice and it was, I have 20 years of experience, so I know the answer. And yeah, it's a very, very common challenge, I will say. But for example, when you're doing your analysis, sometimes I believe that there are some missing data, and that's something that, how do you deal with when you are missing some data in your analysis?
That is the $1 million question. There is a joke in the community that data scientists spend 80% of their time cleaning data and 20% actually developing and implementing models. Definitely, that's a big joke. And it's true, even if I'm more of a data analyst, if the data you have coming in, if it's not clean, if it's not reliable, why would you use it if you don't trust it? We call it that usually companies should have a central point of truth, that from here, you know what is right, and you should supply it to the company and they should trust you. But if you don't take the steps to make sure that it's proper, then it's like garbage in, garbage out.
Garbage out. Exactly. Now, I would like to come back a bit to the initial concept that you mentioned, because you mentioned that in the 90s, it was all about data mining and knowledge discovery. And this reminds me a lot of the concepts that we use in big data. And it also you just mentioned that the work of a data analytic is to clean data and develop models. So this creates in my mind that there's some correlation to AI or to machine learning in the creation of the models. So could you explain me if there is some relation between the world of data analytics and artificial intelligence?
Definitely. But to get into this, I would like to clarify first the different roles that have evolved. Back then in the early 2000s, just one person did everything, from creating the infrastructure, the pipelines, to doing the analytics, to maybe do some predictive models. As the field has evolved, the new roles have been created because the tasks have become more specialized. And nowadays we can distinguish between a data engineer, which is usually a software developer that has become specialized in creating the pipelines, managing ETL processes, extract, transform, and load processes to handle the data. Software developer that has become specialized just in creating the structure for dealing with data. That's engineer. Then we have the data analyst, which they don't necessarily need super strong programming skills, but they do need to be really good at SQL. SQL is the tool that they need. And they usually work with already well-structured data sets, sets that have already been cleaned, usually by the business intelligence team, which relies on data engineers. And with their business insights, with their business knowledge, they go into the data, ask questions, and get the insights to solve problems. That's the data analyst. Then we have the data scientist, which is the newest role that has evolved. Data scientists, a little bit unlike data analysts, they can work with unclean data or larger sets of data. Here it comes a little bit the big data. It's called big because it just means that it cannot be stored in the regular transactional databases that we know, like rows and columns. This type of data doesn't fit there anymore. For example, photos, PDF documents, videos, they cannot be stored, graphs, they just don't fit those tables. Data scientists, after cleaning the data, as we said before, making it a little bit usable, they usually rely on algorithms, what we now know as machine learning, because they deal with more uncertainty. They usually not always come with a business question. That is what we know as data mining. They go into the data, try to apply some models, what we can find, knowledge discovery, and they just start asking different questions. Usually in data analytics, we have the business asking a question, where in data science, usually the person has more liberty to say, okay, what can I find? What can be useful to the company? Okay. That is one of the main differences. And usually the data scientists, they don't always come from rarely actually they come from the business side. They tend to be either computer scientists, pure computer science, and people with really good mathematic backgrounds. They rely a lot on statistics. So anybody who's trying to get into data science, they should have really strong statistics foundation. And it's also very interesting because usually recent graduates, they want to apply the best, most modern machine learning algorithms, random forest. And to be honest, most people just rely on, I forgot the word in English. It's just linear. I forgot the word in English.
Say it in Spanish, maybe we can help you.
Linear regression, thank you. They just rely on linear regression. That's the most simple, but I think 70% of problems can be solved with just a simple linear regression.
Yeah, I think that's the most basic algorithm that you can have, right? Linear regression. Yeah, I remember seeing it.
Useful. And it's basic statistics. So you really need to have your really well basic statistics.
So the role that is most related to artificial intelligence is the role of the data scientist, right?
That's true.
Okay, and just out of curiosity, what is your role right now, or of this that you mentioned?
My title is called reporting specialist.
Okay.
So I'm working on the lowest level of this data maturity level. It's giving reports what happened previously in the company. And every day we do reports on a daily basis, so they can have a snapshot of how is the business doing. We also provide reports on a weekly basis, so they can have a different snapshot monthly. So at the company right now, at this point, it is relatively young, 18 years in the market. And it is a point where we are still just giving a snapshot of how we are doing currently. And like I said before, now that I joined, we are looking forward to create a culture, a data culture, where we can empower the business users to take their own decisions based on the data we provide.
Yeah.
And you previously mentioned that SQL is like your basics. And for example, what tools do you use? Because let's say when I think in SQL, it depends on the engine. I use completely different tool like SQL Server Management Studio, SQL Developer, MySQL Workbench, and we might never finish of so many tools. But for example, as a data analyst, what are some of the tools that you use? Maybe you will use Excel, like, who knows?
Well, definitely Excel is the tool by excellence. Any business user can use Excel, and definitely you can create really good analysis with Excel. What Excel cannot do is that you cannot hold thousands of millions of rows, because actually Excel is, I think you can only have until 2 to the power of 20 rows, and that's it. After that, the file closes. Of course, you can have more in SQL. The advantage of SQL is that it's standardized. I think it has an ANSI standard. But yes, as you mentioned, Federico, there is a problem that every single database management system has its own slightly flavor of SQL, just like a language can have its dialects or accents. This is where documentation is your best friend. For example, in my personal life, in my personal computer, I prefer PostgreSQL, and I was using the latest version. It has many new features, especially working with window functions, which are really useful when you have to do segmentation. And my current job, we are using MySQL, but version 5.7, which is not the newest one, because MySQL 8 already has all the newest features, such as common table expressions, window functions, and I suffer because I cannot use that. So definitely, if you know your basics, going back to this, just like I mentioned with statistics, for SQL, become really good at the basic, how to do a query, how a select works, where works. There is really good information on the web. Person even described how engines execute the statements, because the way we read select from where, is not the way engines execute the statements. So that's really good, insightful for you at how you can make your statements better, optimize them for the engine, so they don't take 20 seconds to execute, especially when you're pulling millions of rows. And of course, rely on the documentation that every engine provides. Let the small features, that will be your very best friend.
So if I understood correctly, you use only traditional SQL in the flavor of PostgreSQL, right? So,
personally, I prefer Postgres, but yes, at work we currently use MySQL. Yeah.
And what about these other flavors of SQL? I would be particularly interested in NoSQL. Is that even used in data analysis?
NoSQL is more like an umbrella term on how to catalog all these other new languages that are not SQL or SQL. That's why NoSQL. But it encompasses things such as graph databases, encompasses such as columnar databases, because of the way they are arranged. You cannot rely on traditional SQL. And it encompasses document databases. So it's more of an umbrella term, and because the way all these other different database management systems are implemented, each of them has developed its own language, and it's really hard to standardize them at this moment. If we look back at SQL, that happened, I think, in the 80s when it was standardized. And today there are so many different, and there's so much competition that I find it really hard that they will come up with a standard just for graph or just for columnar. I find that really tough.
Let's say, what is your prediction about the changes in the SQL environment? Do you think that we'll have new engines or other technologies? Because NoSQL is like, people are constantly fighting. We want to reduce SQL and only use NoSQL. Maybe there is another technology that we might call it a new SQL or something that is completely unknown for us.
I mean, in my opinion, SQL is never going away. Transactional databases are never going away because we use them day to day. It's like how sales work. They are transactions, and we still use them as long as we have them. It will never go away. With this new how to improve the current databases, it's very in vogue. Columnar databases, especially MariaDB and Snowflake, which is like a really big sounding name right now. And it's just a way to implement, for example, the regular transactional databases, relational databases are really good, really fast at writing, but slow at reading, which it's perfect because if you need to register all the sales that you do every second, That's great. But then when you want to do your research, your analysis, it takes a lot of time and your queries can even last 10 minutes just running. And I'm saying a low number. For example, columnar databases are really slow at writing, extremely slow, but they are meant with the idea that they will be used as a second database. So you will have your production database receiving all your data from, and then every day you make a copy and hold it in the columnar database, and it will stay like that forever, and it will never change. But this kind of columnar database is really good at reading. It's super fast at reading, which actually will enable that all your whole analytics team can do queries real time on them, and it will not affect performance. So you can actually retrieve data, retrieve reports, what about node, real time visualizations, and it will not affect the performance. So your business users can say, oh, I have this question, I can go and check them really fast. So that is something that it's currently moving on, especially columnar databases and in-memory. Those are like the strongest buzzwords at the moment in the market.
So do you think that in the future we'll have like combinations, let's say, as you mentioned, that some particular formats of databases are better suited for production, others just for analysis. So do you think that this trend will be more and more popular in the future of having like two different schemas of databases with the same information but with different structures? Or how do you see it?
Yes, it's already happening, and it will continue to happen because they are different tools for different needs. And I think that's the most important thing we need to understand. We hear all the buzzwords, like you were saying, Edgar, that NoSQL wants to kill SQL. They are different. They just have different purposes, and definitely we will continue seeing, especially for recording records. Transactional databases will stay there. Oracle, the giant in the industry, will always have business. But for companies that now also want to make their analysis real time, they will use this data, put it into data marts, data lakes, or special databases, like I just mentioned, in order for their teams, analytic teams, to gather insights from this data. So it's a copy of the current data. And I think also has to do with security reasons. You will not want your analytics team to work on real-time data. Maybe they screw something.
Of course.
Yeah, I agree with that thought. It happens very often that, well, even where I have been working, when the data mining team or the data analytics guys appear and they say, hey, can we have access to your database? It's like, no.
Production never.
That would be a mistake, no?
Like there's this comic from XKCD, Bobby Tables. Do you know it?
I
Not
have
really.
heard just, but you can tell us more about it.
There is a lady who picks up the phone and it's, hey, here is the headmistress from the high school. Did you really call your son drop table semicolon? And I was like, yeah, that's her name. Do you know that we just lost all the students' records from the last 10 years?
Oh my God.
Well, and she replied, well, you should learn to sanitize your database.
That's a good one. That's a good one. Yeah. And now that we are in the topic of SQL, I think that this is a great tool that is widely used. Also, we as developers use it like every day. But now I would like to hear from you. What are other tools that you use in your work besides SQL? Like, I don't know, maybe you use some other platforms. I have heard, for instance, about Tableau or Excel you mentioned at the beginning. What kind of tools do you use in your daily work?
Just like you mentioned, especially in analytics, and like I said before, it's important how we convey our results to the business side. And it's really important how we make it easily understandable with visualizations. There is a huge market for the tools, and it has moved from just having reports in PDFs to make it interactive for the business user so that they can even come up with their own insights. So it's all about enabling them. So right now, all the reg is making it interactive. Tableau is one of the market leaders, and it is my personal tool of choice because it provides a really easy graphic user interface of drag and drop. So even if you are not an IT person, business users can easily get a list of all the metrics and dimensions, for example, that we have in our data, just grab, put them in the corresponding places, X, Y, and already have a simple graph when they can see the insights from the data without necessarily using SQL, which is a great advantage of all these graphic user interface. There are also very well-known competitors in the market, such as Microsoft Power BI. Its main advantage is precisely that it's very familiar to Excel. So any business user that knows how to use Excel will easily know how to learn Power BI. I can name other competitors: Click, MicroStrategy, Looker is one of the new ones. So it's all of them are meant to make it easy that the business side doesn't need to go and rely on the data analyst just to write a query and pull data. They can just easily grab, drag and drop, have an easy graph that they can then present.
And I have seen even new tools where are using data analytics like Celonis that is about process mining. What kind of technology you have seen as this one? Because it's as you said, it's very interactive and helps me even to analyze path of how to, in my case, to build better automations, because it tells me, okay, you need to reduce this and check this and this way. And these are interesting applications that I have seen.
Now that you mentioned Celonis, in process mining, we need to differentiate what they are, because process mining, I think it's more used precisely on processes, not just on manufacturing, but any service that you have a process and it helps you to take it apart and see where you can make improvements. It's especially used on this buzzword of Industry 4.2.0, but it's not exactly what I know about on data analytics. So I would keep it aside for now, process mining, maybe leave it for a second podcast where you can have a person really expert, but that confusion has to do personally with the overlap on terms, because we hear the word mining, which sounds similar like data mining, but it's completely now moving to a different direction.
Now, I would like to ask you, Gabby, all of this data analysis sounds very interesting to me. So if I would like to become a data analyst, or if someone in our audience would like to become a data analyst, what steps should we follow?
First, do not get overwhelmed by the amount of information in internet.
Oh, that's an
Yes,
important one. Yeah.
that's the first step. It happened to me. I was like crazy researching tutorials, lots of articles that precisely tell you what you should learn. Take a breath, do not get overwhelmed.
Okay.
Second step, learn and achieve a competent level of SQL, because it's going to be your everyday tool. In any flavor you like, you can always then consult the documentation and look for the correct term, but become competent and understanding SQL. Third, become competent at a visualization tool. It can be from PowerPoint to Excel to one of the other ones I mentioned, Tableau, Power BI, but it's just a tool. The idea behind this is that you understand how to present your ideas, understand what graphs convey what idea to the business. There are really good communities that I can recommend, and even if they belong to a tool, for example, I follow the Tableau community, but many of the people there also give really good advice on how to visualize. They recommend books on how to make better interpretations, regardless eventually of the tool you use. So coming back, and of course, fourth one, that I forgot to mention, and especially also because I'm a Toastmaster, communication skills.
Oh,
Really,
yeah.
communication skills is we tend to forget them in IT. But going back, if you don't know how to present your idea, persuade and influence the business side to implement it, you are useless. So going back, do not get overwhelmed,
Mm-hmm.
become competent at SQL, become competent at a visualization tool, and learn how to present your idea.
For amazing, amazing. And just like to complement this question, we know that there are many people in our audience who are working as freelancer. So they are not really into the corporate world. Can someone with such a background as a freelancer work also as a data analyst? Because we know that there are like many non-disclosure agreements and confidentiality issues. So is it possible to get a job as a data analyst as a freelancer?
As a freelancer, definitely it's doable. I personally, I don't know freelancers. I know a lot of consultants. The
Consultants.
consultants, which could go on the same line. My only recommendation would be to become expert in a certain industry, because domain knowledge is eventually really, really important. If you don't understand the industry, it will be really hard to gather insights. You would only be a data producer and gather data, but without getting the real insight. So whatever is your industry, stick to it. Whether you go to aeronautics, health, marketing, sales, but stick to it, and then is where you gather experience and you can really provide value to the company on a project base.
And now we're going to move to the part of the predictions. And it's important that maybe you can tell us how do you see the future as a data analyst? And most importantly, how everything related to the COVID changed this trend?
It's a very good question.
Mm-hmm.
I think I had not really given much thought about it. There is some buzzword when you look at communities, especially in LinkedIn, if you follow other data experts. With all the buzz from data science, some people think that data analytics is dead, or they take data analytics as a junior position before being a data scientist. I still consider different branches of working with data.
Mm-hmm.
Data analytics is never going away. It cannot be automated because, like I said, you need domain knowledge. And
Mm-hmm.
no machine can replace that. A machine can give you the best algorithm prediction, but that's it. Especially now with COVID, coming to the question, everything that we knew before, because data can tell you what happened before and map it really well, it cannot really predict the future. We really do not know what is going to happen. If we take the example of the linear regression, you have a lot of dots in your space, and the linear regression tries to fit a line between these dots.
Mm-hmm.
But what happens? We don't know what's coming on in 2021. What if one of our dots is really outlier, really outlier? This whole year has been outliers. We cannot really map them.
Mm-hmm.
So going back, this year has really shown us that the power of, yes, we know the data in the past, but having domain knowledge on how we can use this data, mix it with our insights, and try to predict or at least foresee what is going to happen is definitely useful.
Those are very wise words, Gabriela. I believe that specifically what you're saying, yeah, we can not exactly predict the future. The future is something that we build. Maybe you can give us some last thoughts for the future data analysts that you are encouraging to join to your career.
I would say take a leap of faith. Trust your own instincts. It's true. I think at some point we all suffer imposter syndrome. You know what you know. If you are technically good, trust what you know, and you will learn the domain knowledge on the go. If you are coming from already an industry and you feel you still need to learn SQL, you need to learn how to present, then gather your strength and go on and learn on the side what you still need. You can always develop. Gather your strength and then on the side improve, and then you will have all the abilities that you need to achieve your goal.
Thank you very much for all your insights, for everything that you are bringing to us. And hopefully we'll see you in the future with us, with a new topic, and most importantly, helping more women to be as courageous as you and join you in the IT sector. Thank you. Until the next time, bye.